Am I audible, everyone? Okay, so yesterday we have covered partitions. Okay, how to work with partitions, and also we have covered one more MapReduce program. So today we will be learning some advanced concepts in MapReduce. So we'll start with how do you write a custom data type. Okay, so basically I'll show you the data and then we'll understand how to solve one particular problem. And to solve that problem, how do you write a custom data type? What do you mean by custom data type? So for example, if you open any MapReduce program that we have already written, you can see that the data type that we take for any input key and input value or output key and output value is long writable text, text int writable, right? So basically what we are doing here, we are actually taking a data type provided by Hadoop framework, which are inbuilt in the Hadoop framework, right? These are the data types which needs to be taken for any key and value that we write from mapper or reducer. Why do we need to always take these data types provided by Hadoop framework? Does anyone remember that? We have already discussed about that. So there is a class called long available in Java also, and there is a data type called string available in Java also. But why do we need to always use long writable text or int writable, such kind of data types for holding these values when you take them as key and value for mapper and reducer? Right, so why do we need to use all the data type provided by Hadoop framework only for taking the data type for all the keys and values? Does anyone know the answer for this? Okay, so basically we have taken these data types for these keys and values. The reason being, remember all the keys and values that we write, that we give as an input to the mapper, and all the keys and values that we write as an output from the mapper, they have to be first stored in the map in the file, right? So that means they have to be serialized. So any keys and values that we first read from the file or that we write into the file as an output from mapper or reducer. See, when we say we are writing output from map or reduce class, what do we do actually? We are just supplying write keys and values, and ultimately context.write will write that keys and values to the intermediate output file from the mapper, and from the reducer it will write it to the final output file. So in both the cases, you are basically trying to serialize the objects. These keys and values are nothing but objects, and you are trying to serialize them into the file or into the disk, basically, right? Serialization means writing the state of an object into the file. Okay. So whatever was your state in the object, state of the object in the memory, the same state you are writing it into the file, right? When I say state, it is nothing but its actual value, right? Whatever was the value during the time when it was in memory, the same value I'm going to write it or store it in the file. So that is called serialization. And when you do when you serialize any object, it should actually be able to save the same state in the file as well. That means the same value of that object should be stored in the file, so that when you read it, when you read that object in, let's say, when do you think the reading happens? The reading of this key value happens in multiple stages. First is, it will happen it during shuffle and sort. So the output that is written by mapper class will be read in shuffle and sort, right? All the output will be combined. So that's where shuffle and sort will need to read the state of all these objects which are stored in the file. That reading is called deserialization. So reading happens there, and reading also happens during reducer phase. The reducer will take the output, right? So that is also one more type of reading or deserialization. And then reducer will write the data into the final output file, that is called serialization. So basically, at multiple stage of map and reduce, there is a serialization as well as deserialization of the object that happens, correct? And to take care of that, Hadoop has provided these data types so that you don't really need, you as a developer don't need to worry about taking care of serialization and deserialization separately. You can just leverage all these functionalities by default using these data types. Okay, so that is the reason why we have to use the data types provided by Hadoop framework. So is everyone clear with this? Did we understand serialization, deserialization part? So Shiva and Santanu, are you clear? So Shiva, basically what I explain is, see, every key and value that you write from mapper or reducer will have to be first stored in the file, right? That is called serialization. And when you read it, it is called deserialization. So when you store that data, store the objects, right? Because every key and value we are taking it as objects. So when you store these objects, you have to take care of serialization. That means the state of the object should be stored, right? If you don't take care of it, it will never preserve the value of these objects from memory to the disk. It will just write empty objects, but I don't want that, right? I want even the objects to be stored with the actual original value. So that is why serialization have to be implemented, and that's why all these types that we are using have already taken care of serialization and deserialization logic. That's why we can use them safely. And when we say context.write key and value, automatically it will be written into the file. Okay, so that is the reason why we need to use all the data types provided by Hadoop framework. Did you understand this now? Okay. So now there may be a need where, apart from using all this long writable text in writable, there may be a need where you may need to write your own data types. In that case, how do you, let's say, use it, or how do you provide serialization and deserialization? Basically, the concept that we are going to cover is nothing but, instead of taking long writable text or int writable, any of them, I may use my own custom object as a data type to represent that data. And when I do that, how do I take care of serialization, deserialization in that object, and how do we use it? That is the concept that we are going to learn, right? This concept will be very helpful in the actual run when we are doing when you are trying to work on a lot of business problems, you will face a need where you need to use custom data types. So that's why I'm going to cover that. So let us understand the problem first. What problem we are trying to solve? So let me open the file with the data which we want to use. Okay. Here, if you see, this data already we have understood yesterday, right? But I want to still take the same data to solve one more problem. It is a transaction data. We have transaction ID, date, user ID, amount, product, city, and payment mode. Now, how do we leverage this to basically solve one interesting problem where, let's say, I want to find out the maximum transaction done by a given user. Okay. Let's first take this example. Let's say if I want to find out the maximum transaction done for every user. Right. So if you look at this, the user ID 400100 has taken $100 transaction as well as $2,000 transaction. So obviously maximum will be 2,000 for him. Similarly, all the other users also what is the maximum transaction. So let's say if you want to find out that, if you want to solve that problem, what is the key and value you should take here? Correct. User ID and amount is the key, right? The user ID is a key and the amount is a value. That is the key value that you are taking, which is good. Now, you know that amount is an integer, so you would have probably considered int writable as a data type to hold that value. Now, along with that, what if I am say, if I ask that, no, you give me the maximum transaction by a given user, but along with that, you also tell me what is the product that he bought, which city he bought that product, and what was the transaction date. When did he purchase that, right? So I want now these information also along with the maximum transaction done by every user. In that case, what should be the key and value? Can you tell me now? So Shiva, tell me which is the key, which is the value. So Raj, you can't take the combination of user product city value as a key, because if you take that as a key, then this record and this record will be considered as a two different record. Then in that case, you will never be able to find out the maximum transaction, because both of these record will be treated as different if your key will be, combination of product city, date, and user ID. As you can see from both these records, the record will change if you take both of them as a key, right? because here date is different, here date is different. So in that case, these two records will be treated as different records. So I can never find out the maximum for given user. I will print both the amount here, right? So yes, yes, that's correct, Raj. So in that case, if you take only user ID as a key and remaining everything as a value, then it would be you would be able to solve that problem. But here, when you want to take everything else as a value, right? Let's say a product or city or transaction date. If you want to take everything as a value, then what is the data type you should use to hold all this data? Which data type you can use? Okay, text is the text is the data type you can use, yeah. But if I use a text data type, then it is difficult to, identify which is a product value, which is a city value. For example, all of them, let's say exercise and fitness is a product. This is also city name. But then if you take this as a text value, then I will not know whether this is product or this is product, right? So it will be very difficult to identify the value of each and every attribute unless you actually do some kind of flag, or you put some kind of identifier before every value. It is not possible to recognize whether this is product or this is product, because both are string only, right? So what I'm trying to highlight is, when you put everything as a text, still you would not be able to solve this problem. If let's say tomorrow I will increase the problem complexity and I'll say that, okay, get me only those products which are exercise and fitness along with the maximum transaction done by user, then you have to know what is a product parameter or value. But you will not be able to fetch that if you take everything as one transaction, one text object. So that is where the problem stays, right? So if you take everything as one text, it is not a good approach. You will not be able to solve the problems using that, because it becomes, it is not a very cleaner way of coding actually. Okay. So in that case, what you need to do is, you need to create a custom object. Okay. So again, that is not a cleaner approach. That will not solve your problems permanently. So we need to use a custom objects where your code will be manageable and it can be extensible also based on the problem complexity. So this is the scenario where we are going to use a custom objects. So how do we use it? Let us understand. I'm going to create a new class. So let us start writing a program here. Everyone understood, right, what we are going to do? Anybody has any doubt? Okay, so let's write a mapper class. So my key is 0. I mean, it's basically long writable, which is a byte offset. The value is entire record, which is a text for me. The key will be, user ID. I'll just take it as text right now. It's fine. And the value is the combination of product, city, date, amount. Right. So that's where we discussed that we are going to use a custom data type. So let me create an object. Let's say I want to create a transaction. There is one class which I want to write where I will store all these values. Eclipse says it is not able to recognize this class, so we need to create a class. I'll create a class. So the transaction class is created. Now we need couple of fields, right? We need amount. We need product, city, date. Okay. We need all these fields. And now we are going to generate a getter setter method for all of them. Okay. If you work with Java, this is called POJO objects, plain old Java objects. It's just like a bean objects where you just define this kind of classes will not have much logic. It has just simple properties and their getter setter values. What do you mean by getter and setter? For example, let's say if you check, these are the properties defined in the class, but everything is private. That means I cannot access their values outside this class. So if I want to access it, I need a get method. Get amount will give me the amount value. Similarly, if you want to set or update the value for this property, you need a set method. This is the reason why we have get and set method for every property. Okay. So this is what I have created. I have created one class or object which basically contains multiple fields with their getter setter methods. Any confusion on this portion? then it is fine, Shiva. Then you don't need Getter Setter, but that is not a recommended practice. You should modify the properties of any object outside the class using Getter Setter method only. Otherwise, there will be some security issues. Okay, so I'll do it again. I'll go to the source and then select all the fields, go to the source, and then do generate Getter Setter. If you do that, you can just select all the properties whose Getter Setter you want to generate, and then you just say OK. It will basically generate Getter Setter for all these fields. Is that clear, Mary? Okay. See, this is how we write a class with a couple of properties and a Getter Setter method. But this doesn't really complete our logic. But we need to also take care of serialization and deserialization, right? Here, as we told, if we write our own custom data type, we need to take care of serialization. For that, you need to implement an interface provided by Hadoop framework. Any object you want to make it a serialization, serializable or deserializable, you need to implement certain interface. The interface is writable provided by Hadoop itself. It should be writable object. If you implement that interface, it mandates you to override or give the implementation of two methods. If we say add unimplemented methods, you can see here that these two methods have been automatically added to your class, right? So this is the write method is for serialization and the read method is for these. Okay. So write method, we will just say out.write and amount. So I have to write now every field that I want to save the. So whenever I'm saving this object, I need to tell Hadoop that what all properties value it should persist in the file. Okay. So that this all stuff you need to write here. Write UTF product So what I have done, when this object is being serialized, automatically they will call one of the method called write of this object, where it will find out what all properties it needs to really save in the object. Right? So whatever property you have defined here, those values will be persisted in the file. Now same way, when you want to deserialize the object, it will basically use the logic of this method. Okay. So in deserialization, what do you need to do? You need to read the data, right? You'll just say, so here I have to read the data, but the important point to notice is the order in which you write the fields, the same order I have to read it also. Okay, write UTF. UTF means Unicode characters. So any type of characters can be written. That's why it is UTF. Right? So you can have product, city and date. They have written in that order. So I have to read them also in the same order. Okay. That is very important. So this is where you are completing your logic of serialization and deserialization. You are just telling Hadoop that please do this when serialization happens, and please do this when you are deserializing the objects. Okay, so our object is ready, which we can use it as a data type for holding any key or value. Is that clear with everyone? Did you understand this portion? That's what we understood, right, Shiva, earlier? Why do we need to deserialize? So basically, when we are actually reading the object in shuffle and sort phase or reducer phase, okay, just 1 second, I will explain that. Just give me 1 minute. I'll answer some other question first. I'm sorry, Mary, I didn't get your question, what you are trying to ask. Please make your question a little more clear so that I can help you answer that. Okay, till that point, Shiva, let me come back to your question. So, see, this is my map phase, this is shuffle and sort phase. And this is a reduce phase. In map, you are storing output as key value, right? What happens in shuffle and sort? You are combining all the values for the same key. Then it goes to the reducer. So what you are doing here, when you say mapper.write, context.write this key and value from mapper, it is called serialization. This portion is called serialization because you are writing key value into the file. Now when you are reading, you are combining all these key values from the mapper into this format. So what you are doing when you are reading, it is called deserialization, right? Once you get this data combined, after that you will write it again into the temporary file, that is again serialization. Whenever you write something in file, it is called serialization. Whenever you read it, it is called deserialization. And reducer, you are again reading this input, right? So that is called deserialization. So at shuffle and sort and reduce both level, deserialization happens. Yes, Mary, I'm waiting for your question. By the way, other people, everyone get it now? Serialization, deserialization. If you still don't understand, then please read these concepts online. It is very useful concept. And I'm sure whenever, if you have done any programming, you would have, experienced these concepts. You have to take care of serialization, deserialization when you do any file IO programming. That Vishal, I should not be able to answer because you need to tell me where will it be. This intermediate file will be in memory or it is in the disk. You think and then let me know. Then I will help you correct that. Yes, Vishal. Where should it be? Memory or temporary file? In memory, okay? No, it is on the disk. So this is what happens here. See, what we are doing is basically, this is my master, these are slaves, and when it assigns this map1, map2 task, right, it will generate output 1, output 2, output 3. But what happens here, when the output is being generated, this output is an intermediate output file, right? It's not in memory. The actual output which is written after processing, let's say this is block B1, this is block B2, this is block B3. So after processing this block data, whatever output you generate, that will be in the temporary file, in the intermediate output file which is stored in the local file system of every machine. So it is not in memory. You can't keep all this data in memory, right? You have to store it in the file because that data will be very huge. So that's why you are storing everything as an intermediate output file. Then you combine this output file in shuffle and sort, and the result of the shuffle and sort also will be kept in the local file system of one of the machine in the temporary directory, not in memory. And from there, reducer will start reading this data and processing it. And whatever output it writes as a final output will be written into HDFS. Okay? So that is what happens. Is that clear? Vishal and Ilya Raja, is it clear? Yeah, it consumes more time, but this is how framework works, right? That is the one of the I would say disadvantage of MapReduce. That is why Spark comes into picture. Yeah, let's not worry about Spark right now, but yes, Spark has a different way of processing the data. It doesn't have this MapReduce paradigm. It is actually processing everything using lineage of RDDs. We will definitely not be able to discuss that right now. But yeah, Spark performs better than MapReduce because it does everything in memory, right? But it doesn't really load all the data in memory unless it is required. So there are a lot of actually concepts that needs to be understood in Spark so that you can understand how it works. However, in MapReduce, this is the approach. And if you really forget something, So if you really want to, brush up, I would request you to kind of go through the videos that we have already discussed on MapReduce architecture. That should give you good, refreshment. It gives you good revision on all these concepts. Okay. So this is about, serialization and deserialization that we discussed. I just wanted to make sure that everyone knows when this method will be called. Okay. So once you have this object created, you will need to use it as a data type. Now I am using this object as a data type to hold the entire record or these four parameters like date, product, city, and amount. Right? That is the values that I am holding it as a transaction data type. So now let me start writing a objects. So I have this record which comes as a value. I want to split that into the columns. And now I have to set appropriate data. So 0, 1, 2. Column 2 is your user ID. And the transaction object is what I have created, which has couple of methods. Set amount. So what is the amount field? Column 3, which is an integer. So you need to parse it as an integer. No, Raj. It is not necessary to set them in the same sequence. You can set them in any order. It's absolutely fine. Okay. For example, let me just change the order of setting these values so that we'll know, right? So this is what I'm doing. Basically, I'm setting multiple properties in this object, right? Like city, transaction date, amount, and product from these values into these objects. Now what you need to do, just use context dot write out key, out value. So this completes my mapper code. Okay. So it's the same MapReduce program that we used to write earlier also, but the difference here is I have now created a custom object where I have provided a logic to serialization, deserialization, the properties which I have to store when you store this object. So whenever you say context.write and when you say output value, which is a transaction object, then Hadoop should know what all properties of this object should be stored in the file. And that we have already told him in the write method. If you open this object, there is a write method where we told Hadoop that these are the properties which need to be serialized, right? And we have already set the values of this property here. So that's how now Hadoop will know that, okay, when you save this object, these are the properties that needs to be serialized. So this completes a mapper class. Is everyone clear with mapper code? Any doubts? Okay, so let's write the reducer now. See, this is what happens in shuffle and sort phase, right? All the values, all the transaction, this from here to here, it is one transaction object. Here to here, it is another transaction object, right? Where the data is different. It's 2/22/2013 date. So 2/22/2013. Okay. So date and amount is changed. So basically this is one transaction object and this is another transaction object, right? So basically from here to here you need to have different objects, and these transaction objects are combined, their values they are combined for the same key, right? So now in the reducer you will get list of transaction objects, and from there you need to find out which transaction object has a maximum amount, and that object's data you need to consider, right? So you will just write the final output as something like this. This is my amount. So you can also check like this, right? You can date is equals to this when the maximum transaction happen, max amount is equals to this, product is equals to this, and city is equals to this. Okay. Let's say this kind of data I need to write it as a final output. So I need to just iterate through all the transaction object and then compare them with the value property, amount property. Whichever is the highest, that object I can consider it for writing it into the reducer. Writing it as an output from the reducer. So what is the corresponding data type? You will have text. This is also, no, this is a transaction object. This is text and this is text. Okay, so let us overwrite the method here. So we'll just take text. Okay, so it is a list of, sorry, it should be a transaction object. It's a list of transaction object, right? Now here, what you need to do in this logic, you need to basically write the, you need to iterate through this object and compare them. So it will be something like this. Let's say I'll take an empty object. Am I audible, everyone? Hello. Am I audible, everyone? Okay. Yes, I was just writing the corresponding output. So you just say transaction dot get city. So what I have done in reducer is I'll just explain you. I get at least of transaction object. Now I want to compare them and find out the transaction object which has a maximum amount. So I have taken one empty transaction object and then I'll compare that object's amount with every transactions in the list, and which if it is less then I'll just replace this object with the current object, and this loop will iterate till I get the maximum transaction amount for a given transaction object. So now my maximum transaction object will be pointing to the transaction object which has a maximum amount. And then I'm just extracting the amount, product, city and date field from that object and setting it as an output value, which is a text object, which I'm going to write it as a output from the reducer. That's it. This is what I do it as part of the reducer code. Is everyone clear with the reducer code? Any doubts anybody has? Okay, so looks like no questions, so that means looks like everyone has got it. So we'll now write the driver code. Driver code, as we discussed earlier also, we don't really need to write any logic in the driver code. It's just some configuration settings, so I can copy paste that into this custom type object. Okay, so I'm just copy pasting that logic here, and I need to basically do this. I'm setting appropriate mapper and reducer class. That's it. Apart from that, input output everything is same. So this is the driver code which I'm writing. Okay. So I have completed my mapper, reducer, and driver code here. Okay, so we are fine with that. So this completes the entire code. Now I'm going to execute it as a jar file. So I have a jar created. I have also the data stored in the HDFS. Let me just go and check. Yeah, under data transaction directory it is there. So to start writing the jar file, Hadoop jar, executing the jar file. Okay, I'm executing this program by giving input as a transaction file and output as a folder that I'm going to create as custom output. Let us see the kind of output it generates. Right, so we got the output. Let's see the output. Okay, so it has created this output where we got the maximum transaction done for a given product and city combination on a particular date, right? So this has been listed here. So this is how we were able to basically generate the final output. Yes, yes, Divagaran. For every key and list of values, reduce method will get called. So is everyone clear with this approach? Any doubts, confusion anybody has? Yes, Mary, that's right. It's like in an array, I have only one number, then it will print only that number, right? So it doesn't really need to compare those two elements if you have only one number. So that is fine. Okay. Okay. So this completes the custom data type object. Now we'll take another problem. and understand how do we solve it using MapReduce. By the way, one thing important thing to notice is how do you decide keys and values here. So for example, let me give you a new problem statement, which is let's say I have a file which contains some numbers 1, 2, 3, 10, 12, 17, 800. All these numbers I have. Now I want to find out the average of all these numbers. Okay. This is my problem statement. Let's say this is a very simple and easiest problem, but let's understand how do we approach it. So here I have these many numbers, as you can see, and all of these numbers are basically stored in the file. These numbers would be, let's say, about 1 million numbers, so huge file. But I want to get the average of this number. So what should be the key and value that you should take so that you will get average of these numbers? Can you tell me here what should be the keys and values? Just by looking at this data. This is very interesting. Nobody wants to try? Okay, Raj is trying. Yeah, Raj, go ahead. Yeah, input key value, it's fine. Byte offset and that entire record, that is fine. But then what is the output key value that you are going to write from the mapper? Can you tell me? Okay, so I think some people are giving different suggestions. So let me tell you what should be the key and value. See, in the map phase, you will have to take key as, see, for example, take this first value, right, 1. So see, it's important that if you want to find an average, right, all these numbers should go to the reducer where you can do the average, even if there are 1 million numbers. So I have to take key which is a constant key. Let's say I can write some word as constant. This is my key and the value is the actual number. Then for the next record also I am going to write the same key which is a constant key and the value is 2. Similarly constant and the value is 3. So and so forth. Right? Now in shuffle and sort what would happen? All the values for the same key will be combined. So what would happen here? Constant is the key and all the values, that means 1, 2, 3, 10, 12, 17, 800, all this will be written as a list of the values. And then finally, you will go to the reducer. In reducer, what you are going to do? You are iterating through all these values and then taking the average. That average you will be printing it into the output file. So is that clear with everyone? This is actually one of the interview questions that people might ask actually. So just giving you this technique. So this is basically a technique through which you can solve a problem of finding an average of huge numbers. Is everyone clear, by the way, on this approach? I'm just taking one static key for all the values so that they will be grouped together and given to one reducer where you can do the average. Is that approach clear with everyone? Any doubts? Am I audible, everyone? So, Vishal, others were able to hear me. I think there was some issue at your end only. Right. Basically, see, I wanted to solve a problem where I wanted to find an average of all 1 million numbers. So the way you write keys and values is very critical here. In mapper, I am writing key will be some constant word and value will be the actual numbers. So what happens, all the values for the same constant key will be combined like this in shuffle and sort, and it will be given to the reducer for doing the average. See, calculating the average of all the numbers, it's very important that all of these numbers will go to the reducer at once. That is why I am taking the same key, so that all the numbers will go at once to reducer and you can get the actual average. Is that clear? Anybody has any confusion on understanding this problem? If not, let me go ahead and write the problem. I'll just write average as a class name. Calculate average, or rather. I'll be basically using the MapReduce program from the other jobs itself, because we already tried understanding this, so we don't need to change much here. Okay, so here in the average mapper, you need to write this portion. I'm just removing it as, let's say, 1. So here the key will be something like this. Constant value is 1. So long writable text, and writable, fine. And there is no need of splitting anything, basically. It's just one record. So I'll just use the key as a constant word itself, and the value is record.toString. Okay. This is my mapper code, right? And similarly, in the reducer code, what will happen? The reason why I'm covering this problem, because these kind of problems are asked in the interviews by people. So it's really important that if you know one technique, you can use this technique in many other problems. 1, 2, 3, 10, 15, 20, whatever. So here in the reduce, also what used to happen is you are taking a maximum, iterating through all the values, or not maximum here. I need to get the average, right? So average. Okay. So everyone clear with the reducer code? Okay. This completes my average code. Any doubts on this average program we have written? I'm sure by seeing all the other programs, it becomes easy for you to visualize, right, what we are doing. One only difference here that I am doing is null writable. Null writable means I don't want any, see, I don't want to write this key as a constant, right? That doesn't have any meaning. At the end of the output, I should have just average of all the numbers. So that's why I'm just saying null writable, which means it will not write any key, only the value it will write. Null writable is an object which is given by Hadoop, so that if you don't want to write any key or value, you can just set it as null writable. Okay? And remaining things are stands as it is. So let me just create a project, and I will also create some file numbers. I'm just putting some numbers. Okay, I have to copy it in SDFS. Now I can execute a jar file, the same jar which you have created. Okay, so let's see the output once we execute this as a map reduce. Alright, so the output has come. Let us see the output. You can see the average of all numbers. It is printed like this. Okay. So is everyone clear how to find the average of all the numbers, million numbers using MapReduce? And I have a question. Can we use a combiner here or not? Yes, very good. So you can't use a combiner here, right? So this is how you solve a problem of doing any operation on large number of data, right? So you may have questions in interview like how do you sort numbers, how do you find a maximum out of 1 million numbers, how do you get the average, how do you do a lot of other stuff, right, using these numbers. So when you get such kind of questions, remember the technique is to get the constant key and the value, and with that you will be able to solve this problem easily. Okay. So once you know the right keys and values, after that the problem become very simple to solve. All right. So any further questions on this topic anybody has? Okay. So I think, so Mary, I will not be able to solve it right now. You just send me a mail with your issues. I will respond to that. Okay. Yeah, just send me an email. I will respond to that. Okay. So I think let's take a break now. We'll come back after the break and continue further. All right. See you all after the break. Hello everyone. Hello everyone, am I audible? Okay. Uh, by the way, everyone has got a mail to for the extension of the class, right? Like we have 2 more days extension on this batch. So everyone has got a mail, right? Okay. So that's good actually. So we'll be having 2 more days of extension on this classes. By the way, before I move forward on the MapReduce, I just wanted to make one announcement that I have some personal emergencies because of which I need to end today's class little early. I have a doctor's appointment and that's why I have to do that. But then apart from that, what we'll do is before we start a new topic, let me just walk you through some distributions of Hadoop. We'll cover that first so that at least we'll have an idea about what types of distributions available in Hadoop. So I'll not take any new concepts in MapReduce right now because that is going to take more time. Yeah, so I'll just share the slide with everyone. Can you all see my screen? Okay, so we'll be basically talking about a couple of distributions of Hadoop that is available as part of the industry. Like one is the cloud era distributions, which we are already working on, right? And I have also helped you understand how to install that. how to use it. So Cloudera is a commercial vendor for deploying Hadoop in an enterprise, and it uses 100% open source distributions of Hadoop and related projects like Big Hive, HBase, Scoop, and so on, right? And it offers the user-friendly Cloudera manager for system management and basically monitoring all the services on Cloudera. So Cloudera's distribution is known as CDH, Cloudera Distributions of Hadoop. Uh, it delivers the core elements of Hadoop, and this is the architecture, as you can see, which helps you to understand what all components that can be included in Cloudera. So, as you can see here, there is a MapReduce Hive Pig for batch processing. There is Impala for real-time query analysis. There is a Cloudera Search. There is Spark and Mahout. And then you have HDFS, HBase, Yarn, Scoop, Flume. So these are the components which comes as part of Cloudera distributions of Hadoop. So when you install CDH, all these components are automatically embedded in Cloudera distributions. Okay, where the core Hadoop, which contains HDFS, MapReduce, and Yarn, that is available. Along with that, you have Spark. Spark is available as a in-memory processing framework, but Spark can also, it's already installed by the way. So this VM which I have shown you, right, which also has Spark installed, just to highlight a point that whether Spark is running here, I'll just quickly execute one of the Spark service so that you all know that yes, Spark is running fine. So to make sure Spark is running here, I will just do this Spark shell. If you open Spark shell, it will take you to the Spark shell where all the Spark, where you can write all the Spark programs using Scala prompt and process the problems. So as you can see, the Spark has started, okay? So what I'm trying to highlight a point is even this version has its Mary, I will anyway cover one example on XML file. Okay. So XML file we will see where you understand how do we process that also. Normally, MapReduce in any other I mean, if you attend some other training from some other trainer in Simplilearn itself, they don't cover all these concepts, right? But I know that MapReduce is critical, hence we are covering a lot more concepts. So we in fact have to cover joins as well as XML format processing. These concepts we need to cover. So I'll be covering that. Okay. All right. So yeah, this was about Cloudera distributions of Hadoop, which you need to understand. So then similarly, all this, it has given you steps to install the Cloudera distributions of Hadoop, which we already have seen, right? Same way, how to import it. So I'm sure everyone knows that there is an installation guide which I have shared through which you will know that. What is Hue? I'll cover Hue once we cover Hive and Peaks. So there is a component called Hue in Cloudera UI. If you can see here, there is HUE component. If you just click on that, it will basically take you to the console where you can actually write all the queries in a UI based editor. Hive, Pig, all these queries you can write here itself. Now, just one second. Yes, so this is about Cloudera Manager, and then in Cloudera Manager you have all the services running here where you can start and stop any services at any point of time. Okay, it shows you that which all services are running in a good health. What can you start, what can you stop. So it's like a management console, admin console, through which you can stop and start any component services at any point of time. You don't need to execute commands through UI itself, you can do it. So it's a better manager UI for management of all the services. Okay, so that is about Cloudera. Then you have Hortonworks. Hortonworks is another platform which also provides you a similar kind of Hadoop distributions. It actually has components like SDFS and Yarn and MapReduce. Along with that, it has its own components, which is Ambari. Ambari is similar to Zookeeper. We'll cover Zookeeper in the session when we talk about HBase. Basically, difference between Hortonworks and Cloudera is they have different way of packaging Hadoop component. That's it. Both of them are using the open source Hadoop only, but they have their own way of packaging it. Even Mapr is another company who actually gives Hadoop distributions with a lot of components integrated into that. So Mapr, Cloudera, and Hortonworks are the competitors for Hadoop distributions, but Cloudera has captured majority of market shares because of the wide popularity of Hadoop distributions given by them. Cloudera is a company started by the same guy who have written entire Hadoop, who is called father of Hadoop. Hence, it was very popular. Okay, then you have something called Pivotal HD. Pivotal Hadoop is developed by EMC or Pivotal company. It actually is a company which was owned by EMC Square. It's a proprietary product of EMC. It's not open source. So if you want to use Pivotal HD, you have to purchase a license for that. It will have its own components along with Hadoop, which are basically written on top of Hadoop so that they can provide faster query processing. Like Hawk is one of the advanced database services which provides the SQL analytics over the data stored in under Greenplum. It's a data warehouse. So they have given this Hadoop distributions which can work seamlessly with Greenplum, which is also a proprietary product of EMC. Basically, Pivotal HD is a licensed version. Similarly, IBM InfoSphere Big Insight is also a Hadoop distribution, but that is proprietary Hadoop version by IBM. They have customized it to their needs. It is also very costly. It has its own license. So these are some distributions that I just wanted to talk about, just to give you an idea that what all different types of Hadoop distributions available in the market. Okay. Now we will talk about a Yarn architecture before we move forward on any other topic in MapReduce. I want you to understand what is Yarn architecture. So everybody knows, right, why Yarn is developed. So initially, let's say when in Hadoop 1.0, there was only MapReduce and SDFS. Okay, so MapReduce used to process data stored on SDFS and give you the results. So whenever you want to process any data on SDFS, you have to write programs in the form of MapReduce. There was no other alternative approach through which I can process the data other than using MapReduce. But that was a limitation, and hence in Hadoop 2.0 version, yeah, can you see it? So in Hadoop 1.0 version, MapReduce and SDFS were the components where MapReduce was processing data on SDFS. So you cannot write any other distributed programs other than MapReduce to process data on SDFS. So that was a limitation. So in Hadoop 2.0 version, they have come up with something called YARN. So what happens now? You have SDFS. On top of that, you have YARN. And on top of that, you have MapReduce. So let me just write it in this fashion. SDFS, YARN, MapReduce, Spark, Storm, MPI, etc. So basically now, because of the YARN, you made this framework as more generic. YARN is called Cluster Resource Manager. Okay. So now that framework has become more generic, right? So instead of processing the data on SDFS using only MapReduce, now you have options. You can actually choose to write distributed programs using Spark or Storm or MPI or any other framework or MapReduce. YARN can understand all of them and then process the data stored on SDFS, right? So that is why with the help of YARN, it becomes more generic in your architecture that you can use any other distributed processing technique other than MapReduce to process data stored on your SDFS. Are we getting this advantage? Okay, so now I'll show you the architecture of YARN, which is not there in PPT, but I'll draw it here, which will help you to understand how a MapReduce program can be executed using YARN. Okay, so we'll understand now how it can be executed using a YARN server. So there is so you should now visualize your cluster in this fashion. Okay. So you have a name node and data nodes. You have job tracker and task tracker, right? Earlier this was the problem. Now what is the and job tracker used to submit all. See, if there are 100 clients who are submitting MapReduce programs to the job, client 1, client 2, client 3, if all of them submits MapReduce, it has to go via job tracker and it will only execute all the 100 MapReduce programs. It will only assign the resources for them, do the failure management. If any task fail, it will only do failovers, and it will only do assignment of the task to different task takers and monitor the status. So there was only single guy called job tracker who is responsible for executing the entire MapReduce job as well as the resource management on the cluster, right? So it was overburdened. The responsibility of task tracker was overburdened, and hence it's like, if you want to understand it in a very simple terminology, you have a company where you have one director and 1,000 employees. Now the same director does the monitoring of day-to-day work of all the 1,000 employees. In that case, what would happen? The director will basically have to do a lot of job in terms of monitoring the day-to-day task of every employee, as well as he has his own work. So he will be overburdened, right? So that is what happened in case of MapReduce old architecture, which has job tracker and task trackers. So in Yarn, what happened is they have actually introduced a new process called resource manager and node manager. Okay, which are basically doing only the resource management, and the MapReduce job execution will be done by another process called application master. So I will explain you this, how does it happen. Okay, so this is, let's say, so I'll not go into the detail architecture of how MapReduce executes because we have already covered that in detail. So I'll just cover a high level difference in terms of what changes Yarn has made. Okay, so this is resource manager, this is node manager and data nodes. Every slave machine will have a data node and a node manager. Data node and node manager. And every master will have task node, resource manager and a name node. So this guy goes to, whenever let's say you have executed that Hadoop jar command, the job client will go and check with the resource manager to get a new job ID. He will save all the information in the SDFS. All of these things we have discussed, so I'm not going into detail about that. Under this job ID, it will copy the jar file, the input path and the output path of the file, right? Everything will be stored here. Now what happens? He will submit the job to the resource manager. Now once the job is submitted, the resource manager, instead of job tracker, where job tracker was earlier architecture, it used to directly execute the MapReduce programs. Here it will not execute this MapReduce program. This job ID would automatically be put it into the job queue of resource manager, and here basically J1, J2, J3, all these jobs that you have, for example, all these jobs, right, will be picked up by the resource manager, and he will take one of the job and then try to execute it. Now when he takes this job, what happens is he will basically have to execute it as a MapReduce, but then resource manager doesn't execute it. What it does is he will assign this task to one of the node manager and tell him that can you launch an application master. Okay, application master is one more Java process written by Yarn framework. So node manager will basically run this application master in a dedicated container. Now what is this container? Container is nothing but it will have dedicated CPU, RAM, all these resources allocated for application master. Okay, now what happens is this application master will basically start executing this entire job as a MapReduce job. So what it does, it will basically go and, so see, the application master, once it is launched, it will go to the resource manager and tell him that, okay, get me the job ID. Once he has the job ID, he will go and read the jar file, and then application master will do the job of job tracker, which is nothing but it creates a map task and assign this map task to, let's say it had to process a file which had two blocks, 1 and 2. Then it will assign map task 1 to one node manager and probably map task 2 to another node manager, right? And they will be running in the separate VMs and process this data. They'll generate the output, and again, it will be like complete map shuffle sort and reduce phase. So application master will take the responsibility of executing the MapReduce program in the map shuffle sort and reduce way, right? So if there are, let's say, 10 MapReduce programs submitted on Yarn cluster, then 10 instance of application master will be created on different node managers. Okay, so now there is a dedicated application master for every MapReduce execution, so that it will just have to focus on that particular job rather than executing all 100 jobs execution, right? So it's like earlier example which I gave you, we have one director and 1,000 employees. Now I have one director who has hired 10 more managers under him who takes care of managing 10 different projects, and they have dedicated people assigned to them, right? So instead of director does all the work, he has hired few more managers who can help them do their work, right? So it's like better delegation of your responsibility. So that is the principle design. It was a basic design principle which was considered when yarn is developed, so that every process is responsible for doing every work. Vishal, it all depends. Like whenever you want to execute a map reduce job, then only application master is created. Once let's say that job is completed, when reduce phase is completed, when the application master send a signal back to the resource manager that I am done, the resource manager will update the client that your job is successful, and at the same time he will kill the application master which is running. So, in a normal environment, director will give reward to a manager if he completes a work. But here, an application master will be killed by resource manager, right? Because his job is done, so he will be released, his resources will be released, and it will be used for further job execution, right? So the application master will not be running always. It is just triggered only when it is required to execute any MapReduce program. But it will always be running in one of the node manager machine only. But resource manager will decide which node manager it should be running. Okay. If you have submitted two MapReduce program, it will launch two application master. Both of them are running in two different machines, two different node manager machine. Is that clear? So are we able to follow what I have just said? Vishal, are you clear with your question? Yes, yes, all this is internal. We don't, in fact, all the MapReduce program that I have executed, I have used Yarn as an internal framework, right? Because that is the latest version of Hadoop we are using. So it is Yarn only by default. So we don't really need to worry about anything else. It's for developer, it is completely black box. But I'm just giving you some internal details on the architecture front. What about others? Are we getting this? All right. So one more important point to consider is, see, this architecture that we are seeing here is fine, but then how does it make it more generic? See, this is something that we have understood in the form of MapReduce. I have not actually covered the full MapReduce execution because what we have already discussed that in the earlier architecture, right? So I have just given you the difference of different processes that can be launched for YARN, okay? So we don't really need to worry about how internally MapReduce gets executed. That is something which is the same which we have discussed earlier. I'm sorry, Raj, your question doesn't, I'm not able to understand your question, but if you are trying to ask that how do you combine the intermediate output, then application master will combine the intermediate output of all the map tasks. It will combine it, right? This is where it will combine and then give the result to one of the machine. Just like job tracker. You don't need to go to the name node machine to combine it. Application master, wherever it is running, it will combine there and then give the result and store it into one of the machine. Okay. Okay, fine. No problem. So, yeah. So basically, see, the important point to understand here is how does it make it more generic? See, so for example, how does it know? See, if I want to execute a Spark program instead of MapReduce, then we say that Yarn can execute that also. But this is just the same architecture. So how does it interpret that? So what it has done is, it has in fact, used a. Let me just show you this. So it has actually taken something like this. For example, uh, you have an application master as an interface, and if you understand the object oriented programming concepts, this is called inheritance. So there is a MR application master. It's a class which is written which implements this interface, and there is a Spark application master which is written. Basically, both of them, what do? They actually implement this application master interface, and both of them are trying to execute your MapReduce programs. So there is an MR app master and there is a Spark app master. MR app master will do the job of executing the MapReduce job. So now resource manager, when let's say you submit a MapReduce job to resource manager, based on the type of the job, resource manager will launch the instance of MR app master. If you have submitted Spark job to resource manager, it may launch a Spark app master, you know, in one of the node manager. Now MR app master, once you launch, it will know how to execute a job in a MapReduce way, and Spark app master, if you launch, it will know how to execute a job in a Spark way, right? Likewise, you have Storm application master, MPI application master. So these application masters are dedicated for executing one type of program. And that is why we say that Yarn has support to execute all these different types of distributed processing framework. Because Yarn already has this inbuilt application master available who know how to execute a particular job, right? So that is why it makes it more generic. Are we able to follow what I have just said? Okay, so actually that's what I wanted to cover as part of Yarn. So this is just to give you an information that Yarn has done what all changes. So basically it is making your framework much more generic so that now you can execute any other program other than MapReduce. You can execute Spark or Storm or any other distributed processing framework. Apart from that, because of Yarn, you are also able to do more resource management, right? You don't really have to have only one process overburden to do all the tasks. Now you have dedicated application master who can execute different jobs on its own way, right? And once the job is completed, you can kill this particular application masters and release the resources of that application master. So basically, you can use the resources in a better way only when you need it, you use it. Otherwise, you make it free. So it's a better resource management which is available with Yarn. Unlike job tracker, task tracker, where job tracker was always occupying a lot of resources. Here it doesn't. It's not the case. Resource manager will allocate the task and assign resources to that task only when the task needs it. Otherwise, it will just free up the resources. So it's a better resource management as well. So these are the two major functionalities that was achieved by Yarn, and hence it is definitely more robust framework to work on. Okay, that's why many people prefer Hadoop latest version because it has Yarn. So anybody has any more questions on Yarn? All right. So, as I said, that's what I had for today's session. As I said, I need to finish little early for today's session as I have some appointment. So we will meet tomorrow at the same time and we'll continue further. Okay. So tomorrow we'll see a couple of more advanced MapReduce programs and then we will start our next topic day after tomorrow. Yeah, Mary. I will respond to that. No problem. Okay. So thank you everyone for your time and have a good day. We'll see you tomorrow at the same time. Thank you.